So today I'm going to present my PhD thesis, which I completed last year. And this is about testing DSGE model for UK economy, where we have imperfect pass-through of exchange rate to CPI price level. Today my presentation has 5 parts, so I'm going to start with motivations. So before we proceed with my paper, first let's define what is the exchange rate pass-through. Yeah, so this is the impact of exchange rate on price levels, and price levels could be any price levels, tradable prices, non-tradable. It could be final prices like CPI. Okay, for tradable prices, literature most has done on import prices. And the mathematical definition of exchange rate pass-through is a change in price level over the change in nominal exchange rate. So this is the official definitions. Now, pass-through coefficients is estimated to be between 0 and 1. Yeah. So why this is the case? So if we look at these equations, yeah, so to be this degree to be between 0 and 1, the change in the prices has to be less than change in the nominal exchange rate. So why this is the case? Because nominal exchange rate is more volatile than the CPI price levels. Yeah, because the financial market has a huge impact on the nominal exchange rate, and whereas the prices are more rigid, and why the prices could be sticky. So by sticky, we mean when there is a shock in the economy, prices doesn't change instantaneously. So why this might happen? Because of some costs, like a menu cost. This is the cost to consumers for changing the price. So in my thesis, this is the main reason, I assume, so price rigidity. It could be other reasons like variable markups, where the firms tend to change the markups rather than prices, or it could be the low inflation environment. So for example, like advanced economy, where we have inflation targeting. So all the firms know that the central bank is controlling the inflation rate in the medium run. Yeah, so they are not going to change the prices because they have expectations that the price level is going to be stable. So they are not going to change their prices. That's why the prices could be rigid. And actually there are other reasons, a lot, but here in my thesis I assume that prices are just rigid because of menu costs. The past literature now estimates the pass-through to be between, actually it's usually between 0.1 to 0.7 or 8, usually not, rarely over that degree. So what does 0.1 means? It means if we change exchange rate by 1%, the price level is going to change by 0.1%. Yeah, so it's quite small. So from this to here, we can see that the pass-through to import prices is larger than pass-through to consumer prices, which makes sense because exchange rate first affects the import prices and then affects the price CPI price level, which is the final price level. Yeah, so this is all has to do with the transmission mechanism in the economy. So this is the dynamics of economy we are going to discuss in the following slides. The final thing I want to talk about the speed of convergence. So this has to do with imperfect pass-through and perfect pass-through. So what does imperfect means? As the name suggests, the change in the prices not equal to the changes in the nominal exchange rate. So the parameter will be less than 1. By perfect pass-through, which we assume in the long run, where all markets clear, everything is flexible, yeah. So the changes in prices has to be equal to the changes in nominal exchange rate. So pass-through is equal to 1. And since we are here in my thesis, we are going to discuss about the dynamics of economy because this is a DSGE model. Yeah, so we will see how the short-term pass-through converges to the long-run pass-through, which is equal to 1. Okay. Next slide. So my data is UK economy. So here I present the data for two variables, exchange rate and the CPI price levels. This is the annual changes. Yeah, the blue line is exchange rate and this red line is the CPI level, changes in CPI level. So this is the data between 1989 and 2017. So let's look at some episodes. Yeah, let's say 1992. UK has left the EU common exchange rate zone, yeah, union. So from this date, the exchange rate has been flexible for UK. So on this date, we have a sharp decline in exchange rate, but not as much decline in CPI level. The same in 1998, we have at this date, the Bank of England adopted the inflation targeting. So after they adopted it, as you can see, exchange rate declined, yet depreciated, and then it became stable. So over this period, you see we have a sharp increase, sharp decrease, but the CPI price level was quite stable. And actually from this graph, you can also see that inflation targeting was quite successful in United Kingdom. So the inflation rate was quite stable. Until 2008, where we have a sharp drop in exchange rate, whereas the price level again was moderate. The changes are moderate. The same pattern can be observed in 2016 when the UK has left the EU zone, yeah, the Brexit. So again, exchange rate has declined a lot, but the CPI level increased just slightly. So what do we conclude from this graph? We can make two conclusions. The first one, the exchange rate is indeed imperfect. Why? Because sharp increase or drops in exchange rate, but moderate changes in CPI levels. The second one, the pass-through degree is different. Yeah, so change because the changes are different. So this has to do with my research questions, the second research question. Why pass-through are different across the time? Because the shocks hitting the economy is different. Okay, so for example, in 1992, the shocks will be the monetary policy shock, yeah. In 2008, this is the financial shocks, and here in 2016, let's say investment shocks, yeah, because in 2016, we have a drop in investments and a drop in consumer confidences. So this is my research question. So first, I'm going to evaluate the model, DSGE model. Why we need to evaluate the model? Because majority of literature, they don't test the model. Without testing the model, we cannot use the model for policy analysis. What does testing the model means? It's just testing whether the model is correct, whether the model fits the data. Yeah, it's quite important. Usually the literature just calibrates the model or just estimates the parameters, but almost nobody tests the model. And the second one is we need to talk about the shock dependence of the pass-through degree. So as you can see, I have classified my literature into three. Yeah, so we have three models for estimating the pass-through degree. The first one is the simple regressions, as we all aware. The second one is the WAR models, and the third one is the general equilibrium models. So this is DSGE model. For simple regression models, yeah, we just have one equations, and here we have regress the price level on the exchange rate. So we estimate the impact of exchange rate on price level, and the coefficients in front of exchange rate will be the pass-through degree. Yeah, it's quite simple, and this is usually shows like the average pass-through degree over the time. Yeah, so this model is quite useful when you just start the research question. So it gives you the general idea what the pass-through, the average pass-through degree will be. but it's not quite useful for policy analysis because this is a partial equilibrium models. It's a quite narrow data. Yeah, we need a general equilibrium model to see what is happening in the whole economy. And another problem with simple regression is we have an endogeneity problem because exchange rate and price levels are endogenous variables rather than exogenous. Next one is a VAR models. That's why people use the VAR models. VAR models, a prominent example is the Bank of England paper by Forbes et al. So this is quite similar, my model is quite similar to this paper where they talk about the shock dependence nature of the pass-through degree. Yeah, this has been for UK data. And finally, we are going to talk about the DSGE model. This is a general equilibrium model, so it's this is for the whole UK economy. And my model is based on the standard Smith and Waters model and the open economy of the Monticelli. So in these slides, I just put the estimated pass-through degree for UK. So as you can see, pass-through degree is quite small, yeah, for UK, and if you look at the magnitudes are different for short run and long run, and also the signs. You see the difference, sign are different. And in the following slides, I'm going to explain why the sign are different and why the magnitudes are different. Also here, I present they are also different across the models. Here we have regression models and we have VAR models, structural VAR models. For UK, nobody has used the DSGE models. So this is my paper is the first one to estimate it. Now let's talk about the DSGE model. So DSGE model is a general equilibrium model. So we are going to look for the dynamics. Yeah, it's quite important. So our main variables are exchange rate and the CPI. Yeah, and how it's going to work in the economy. So let's suppose there is a shocks to the exchange rate, like let's say foreign interest rate shocks, yeah, or UIP shocks. So it's going to affect the CPI level by 3 channels. First of all is through the aggregate demand channel, so relative prices. And the next one is through import prices. In my model, we have 2 imported prices. One is the consumption price, one is the input price. The imported consumption price is quite straightforward because there is a kind of part of the CPI baskets. Yeah. For imported input price, it goes through the marginal cost and affects the CPI level. And then there is a second pattern. Yeah, because this is a general equilibrium. CPI level also is going to affect interest rate and nominal exchange rate. So CPI level affects interest rates through the monetary policy, and monetary policy affects through the UIP equations. Yeah, also interest rate going to affect through the UIP equations, the nominal exchange rate. So this is a difference between the partial and general equilibrium model. In the partial equilibrium model, there is just one straight line from nominal exchange rate to CPI level. Yeah, but in general equilibrium model, you see the dynamics goes in both ways, from nominal exchange rate to CPI and from CPI to nominal exchange rate. So this is a main difference between these 2 models. And that's why the pass-through degree is quite different for 2 models. So this is kind of a summary by mathematical. Yeah, so partial and the total effect of nominal exchange rate could be expressed as partial differentiation, total differentiation from mathematics. Yeah, we know. So for partial equilibrium model, this is a partial effect, yeah, partial differentiation, where we have, this is a partial on the left side and the total differentiation on the right side. They will be equal to, in the short run, this is not equal to, yeah? Because here the X variable, this is all other variables in the model. So usually when the literature, they do the partial equilibrium models, they omit this X variable. X variable can be anything. For example, interest rates, yeah, relative prices. So they kind of abstracting from this, but this is kind of a crude estimates because in the economy, everything has linked to each other. Yeah. So this is the difference between partial and general equilibrium models. Now let's talk about the DSGE model. So the standard DSGE model is kind of classifies the whole economy to the 4 parts because we have 4 individuals. First one is the households, and the main objective is maximize utility. Then we have firms. In my model, we have a lot of firms. I think 4 types of firms. We have 2 importing firms, and 2 domestic firms. Okay, and all they do the local currency pricing, so they price all goods in sterlings. The third individual is a government, which satisfies the budget constraint, so taxes equal to the bonds, yeah, the changes in the bonds value. And finally, we have a central bank. This is a monetary policy, and we assume that it follows the Taylor rule. So in the following slides, I'm going to talk about the household and firms because government and central bank is quite standard, just 2 equations. Okay. For example, the households, they maximize utility. Utility we derive from the consuming the goods and disutility from supplying the labor. Yeah, but we have a constraint because the income are limited. Yeah, so households, they use the income from labor, from profits from firms, which I assume as dividends, and then they have to pay for what they get because they invest in the bonds, they earn the interest rate from the bonds. Yeah, but they have to pay the rental rates. Yeah, and they use this income to consume, to invest, to buy the bonds, and to pay the taxes. This is quite standard for the DSGE model. And we also have another constraint, which is a capital accumulation equation. The simplest definition is that changes in capital is equal to investments. So household has another problem. This is a static problem. Yeah. So households, they have a total consumptions, but they consume 2 different types of goods. One is a domestic goods, another is imported goods. From this problem of households, we derive our main equation. This is equation 2, where the CPI is a weighted average of domestic price, PHT, and the imported price, PFT. Okay? So this is quite important because this shows one of the transmission channel, how the exchange rate affects CPI level. So we know that exchange rate affects import prices, and import prices affects the CPI level. Now let's talk about the PHT. This is the domestic retail price. This we derive, this is because intermediate goods, yeah. PHT is a kind of a retail price, and the retail goods is a production function like this. So to produce the retail goods, we use the intermediate goods, YDT, and imported input goods. Yeah, this is quite standard. We usually the case in our economy, yeah, in any economy, yeah. We use some part of the imported goods and combine it with the domestic goods and produce the retail goods and sell it to the consumers, yeah. So this is the case. From this all equations, we are the 5th equation is our main equation. So here we see that the retail goods is a weighted average of domestic intermediate goods, which is a non-traded good, plus the imported input goods. So this is another imported price which affects the CPI. So this is the second channel, kind of. Here we have dynamics of domestic intermediate goods productions. Yeah, this is quite standard. They minimize the cost, which is paying the labor and paying the rental rates, but we have a subject to some productions. Yeah, then here we derive the marginal cost. Yeah, so this is quite standard equations. And then we go through for the importing firms, and they maximize their profit minus their costs, subject to the production functions. Yeah. From these problems, the main equation here is the Phillips curves. So Phillips curves is usually the relationship between unemployment and inflation, or inflation and output. Yeah, so here the Phillips curve looks like this. Yeah, so about the pass-through degree, so here we see on the right side we have a nominal exchange rate ST, and on the left side we have import prices. So here we can see that exchange rate affects the import prices, but the impact depends on these coefficients, these whole ratios. Yeah, so here's the XCF. This is a price rigidity, which I talked about at the beginning. Yeah, so as we can see, the higher the price rigidity, yeah, the lower is the impact of exchange rate on price level. So from this, we can see that the price rigidity affects the pass-through degree a lot, just from these equations. And we have in our model 4 Phillips curve, 2 Phillips curve for 2 importing firms and 2 Phillips curve for domestic firms. And everywhere this price rigidity parameter is quite important. We also have this price index. Yeah, so indexation means how today price is, how the yesterday price affects the today price. Yeah, so this is indexation parameter also matters. But when I estimated my model, I realized that indexation parameter is not as important as a rigidity price. So here we are. Then we have a government spending, budget constraint, and quite standard Taylor rules. Now let's talk about the methodologies, and I use the indirect inference, which is actually quite similar to the simulated method of moments. Okay, so here I put the two bullet points. The first about the estimations. So first I estimated the model using indirect inference. I also tested the model using the indirect inference. Yeah, so why I use indirect inference rather than, for example, calibrations or Bayesian estimations? Well, we all know that what is a calibration? Calibration is just setting the parameters, a fixed value, yeah, and these values are derived from the literature. But for MLE, I don't use it because it has a large bias. Yeah, so parameter biases. And the third one is the Bayesian estimation, because we have a prior information which is quite similar to the calibrations. So that's why I use the indirect inference. In indirect inference is quite similar to simulated method of moments. So we kind of randomly choose the parameters and simulate the moments. Actually here I don't simulate the moments, I simulate the VAR model in indirect inference. And then I see whether my simulated model is quite similar to the data, model derived from the data. If my model simulated model is similar to the model derived from the data, it means my model passed the data. Yeah, otherwise it's not. So when I estimated the model, my p-value was 0.06. Yeah, so I don't reject my model. My model is quite correct. And here I have a lot of parameters which I estimated. It's quite a lot. So, and all was using the indirect inference. Next one, I tested the model. using the indirect inference. So what the testing means. So here we see the first graph. Yeah, this is about how I falsify my estimated parameters. So assuming my estimated parameter are true parameters for the model, yeah. So when I use the true parameters, I reject the model 5% of the time. This is quite fine because we usually assume that we can make 5% of error, yeah. But if I falsify my estimated parameter by 1%, so if I shift the value of all estimated parameters by 1%, my model is being rejected 88%. Now, if I falsify my parameters by 5%, I reject 96%. So you see my model is quite powerful. The indirect inference test is quite powerful because when I falsify my parameters just 5%, the model is being rejected. The confidence level is 96%. So actually, so that's how powerful the indirect inference methodology is. But it's quite, takes a lot of time to estimate the model, but it's quite worth the time actually. Now, here we talk about the dynamics of the model. Yeah. So these input response functions. So due to the limiting time, I just used just one productivity shocks. Okay. So let's suppose that we have a positive productivity shock. Then the output, we have a non-station productivity shock. So that's where output permanently increase. Consumptions increase, but then over the time the changes is quite positive, but still increases, but not as much as on the impact. Yeah, the same is investments. We have a rise in investments, but because we have a price rigidity, so demand changes less than supply, so we have a fall in CPI inflations. Yeah, and also we have a fall in export prices, so we have a large increase in exports. Yeah, so here you see the nominal exchange rate. We have appreciations and depreciations. Yeah, so it appreciates because the interest rate goes down, and this goes down because CPI goes down. Yeah. From Taylor rule, we know that when we have a decline in inflation, the interest rate drops, and because interest rate drops, so capital flow out of the economy, so exchange rate here appreciates, but then depreciates. Yeah, most of it depreciates. Now, what we can see from this graph, let's talk about the exchange rate pass-through. So we have two variables, nominal exchange rate, and we have a price level. Yeah. So at the beginning, on the impact, the nominal exchange rate here increases. Yeah. But CPI level always decreases. So exchange rate pass-through is negative on impact, but over the time it gets positive because this guy declines and CPI level also declines. Yeah, so pass-through degree on impact is negative and then it becomes positive. So why this is the case? Because in the short run, the nominal exchange rate is determined by UIP conditions. Yeah. But in the long run, we have a purchasing power parity conditions. Yeah, the law of one price. So because of that, the nominal exchange rate depreciates and the CPI level also decreases. Or this appreciating, this is declining. So exchange rate is positive. So this is a summary for all other shocks. In my model, I have 18 shocks. So it doesn't fit the table, so I just put some main shocks. Yeah. So as we can see, the short run exchange rate pass-through could be positive and negative. Usually it's negative, and it all depends on the causality. So as I said in the beginning, that in general equilibrium, the causality runs between CPI and exchange rate. Yeah. So an exchange rate to CPI level. Yeah. So here for different shocks, the main causality runs differently for different shocks, from CPI to exchange rate or from exchange rate to CPI. Sometimes the shock hits the two variables at the same time. So it really depends on the dynamics of economy. So what does this mean in general? In our just simple words, it means when we have a shock hitting the economy, the individuals like firms, they set different prices. For example, if there is a shock to the monetary policies, the firms might change prices a lot, yeah. But if we have a government spending shock, they will change it just slightly, yeah. So this means that the individuals behave differently under different shocks. That's why the sign or the magnitude of the ERPT degree is quite different. Okay, I will quickly summarize them. Here is quite table is like summary on what I have said before. So you see the signs and magnitudes are different for different shocks and timing, yeah, because shocks are different because firms set prices different and monetary policy also responds to shocks differently because this is a general equilibrium model, dynamics change differently. And also the convergence rate to the perfect pass-through also quite different. For example, for monetary policy shock, it just fades out quite quickly in 6 quarters. But for productivity, for interest rate shock has like a strong effect on the economy. So the convergence to the perfect pass-through degree is quite long. Here, I think it's around 30 or 40 quarters, so it's quite long. I think I will just make a summary here. Okay, so what can we summarize is short run pass-through degree is quite different across different models. Yeah, for simple regressions or for general equilibrium models. And why this is the case? Because it really depends on the data, where you have a narrow data or a lot of data. A lot of data means more information. Yeah, for general equilibrium model, we just see the whole economy, and the dynamics goes from nominal exchange rate to prices and prices to nominal exchange rate, which makes sense. And now why the pass-through is different over the time? Because the individuals, they respond to shocks differently over the time. So actually, this is quite simple intuitions, but here in the model, we kind of verified using the impulse response functions and the graphs. So this is a summary. Thank you for listening. Any questions?
Thank you very much. First of all, your presentation was very insightful and comprehensive. Now, I would like to kind of ask our listeners if you have any question. You can use the microphone.
I have a question. It's the thanks for your comprehensive presentation, Dr. Aigerim. May I ask, it's the what the software you used, and it's the when you're simulating, it's the have you obtained it's the elasticity? Did you take that's the all elasticity that's the you estimate yourself, or you take it from the literature? And the second question, it's the same also. This the same. If we will construct in this a DSG model for Uzbekistan, should we our equations they should the behavior represent the behavior of the economy of Uzbekistan, or?
Okay, thank you for the question. So the first questions. I used actually two softwares, MATLAB and Fortran, and I think most of the results is from MATLAB. And about the elasticity parameters, all my parameters, actually not just elasticity parameters, are being estimated. So when we use that methodology in direct inference, we randomly choose coefficients, yeah, and then see whether the model and the data, they are compatible. Yeah, so So that's why every parameters, except just few, I think 8, all of them were estimated, not calibrated. And the second question, if we are going to model the DSGE model for Uzbekistan, it will be quite similar because these both two economies are small economies. I assume it's open economy, yeah? For Uzbekistan, we have an open trade, am I right?
Yes, exactly.
Yes, so it could be similar. Of course, it will be some parts will be different. For example, for UK, for example, we say that I use the local currency pricing. Yes, so I assume that all goods imported goods are priced in sterling, but for Uzbekistan, probably they're priced in dollars. Am I right?
I think it's the price. The price they should be in the either in the trade in the dollar or in the domestic price.
Because for Kazakhstan, I know that almost everything is priced in dollars. So even when we export our oil is also priced in dollars. So you see, some really some things will be of course different in the model. It depends on how they trade, in which currencies they trade. So for the firms, this part will be different, yes. For monetary policy, Uzbekistan also follows the inflation targeting, am I right?
Yes, exactly.
Flexible exchange rate, right?
Yeah, flexible or manageable floating exchange rate.
Yeah, so it will be similar. And you don't export oils, so it's quite the same. Because, for example, if we are going to model for Kazakhstan, we will have to include the export, like an oil sector, yeah? But for Uzbekistan, no. Yeah, I guess. Anything else, maybe?
No, and that's all from my side. It's a thanks. It's the really useful presentation. I got this answer.
Thank you.
Can you add some points on using the advantages of using the indirect inference?
What you mean? What is the advantage of using indirect inference?
Yeah, you mentioned in one of your slides. I think.
I see. So actually, we don't have, for example, in my model, why I used indirect inference. So here we have 3 more methods rather than indirect inference. Calibration, we know the limitation. It's just calibrating the coefficients. Maximum likelihood estimations, we have a large bias in parameters when we have a finite sample, and we have a finite samples, yeah, because our data is limited. And the next one is a Bayesian information, Bayesian estimations, because the Bayesian has a prior and posterior parameters. So prior is also kind of a calibrations. Yeah, so this is the third reason. And that's why I use the indirect inference. But it's like, I'm not saying that these methods are wrong. Yeah, it's like I prefer to use the indirect inference. So we can use, yeah, Bayesian informations and indirect inference. All methodologies has the advantage and disadvantage.
So Dr. Rysbayeva, thank you again a lot for your time. So then we close everybody our today's webinar. Thank you for your attendance and see you next time in our webinars again. Thank you.
Okay, yeah. Thank you.